Right, the chat is really buzzing, and we seem to have 10 participants so far. Yeah, while other people join, like I'll just introduce the Keeping It Simple series and then introduce our host for this session, Dhruv. So the Keeping It Simple series is like an effort that we started at Kernel in KB 8 properly. And the whole idea was to combine conversation and craft in these sessions, which introduce different kinds of topics and then go on to go into a participatory activity, which the participants can actively complete with the host, or it can be an introductory session like we will have today with some theory as well as some demonstration on how it relates to what we do at Kernel in trying to build a better web and different aspects of Web3. So as you can see, we have had many different keeping it simple sessions in the past. And we are very pleased by the responses we have been receiving. And especially for today's session, like we have gotten so many RSVPs. Like this is like we almost got 20 RSVPs for the AI session, which is just reflective of how many people are interested in a topic like this. So yeah, and we couldn't find a better person than Dhruv to walk us through it because he has the kind of experience which all of us have as Kernel fellows to have gone through Kernel. And on top of it, he has been like experimenting with the state-of-the-art AI systems that we have, and also helping build a Web3 company um, and is doing many other things on the side in the fields of security as well. So yeah, I'll stop sharing my screen and we welcome Dhruv to walk us through AI and humans in this session. Welcome, everybody.
Sounds good. Hi, everyone. Hope you're able to see my presentation. Perfect. So thanks, Sid, for a very great introduction about myself, about the program. And I'm, let's say, very much passionate to impart knowledge about how to build first agents, and then how you can, let's say, have that system thinking mindset about how things are working, current use cases of agents on top of transformer models. So Sid has done a great job given introduction, but I do from myself also. So I have done masters in the field of cybersecurity and distributed systems. So during my masters, I started doing thesis about zero knowledge proof, where I first came around Ethereum blockchain as layer one. And since then, participating during hackathons, I came across Kernel in 2021 when Kernel Block 3 was started. And it has been a great experience, not from, let's say, from the technical expertise that Kernel Block imparted, but also the philosophical aspect of Web3 and how it's gonna make, let's say, ecosystem more equitable, and all these other aspects that various guides like Andy, Vivek are imparting. So I have been participating since 3 years. Currently I work with as a co-founder of company Extra Labs, which is trying to build end-to-end pipeline to analyze visual data from LiDAR sensors, from cam videos, to using photogrammetry to create distributed pipeline to create 3D maps, which are up to date, which are crowdsourced by various participants with similar ethos as OpenStreetMaps. At the same time, I also do auditing of smart contracts, and also I'm participant of the Polygon Developer Initiative, which name is Double, and you can reach out to me on Slack regarding any queries related to Web3 development side. And also I'm gonna be host eventually if you come to Paris or Brussels this time when Heat City is gonna happen. So going further ado, I will go, the current discussion will be on the following topics. First, I will give a general introduction about agent framework. Then we'll describe the current design patterns of how to develop agents, define various modules in the agents. And then I will explain, give some references of examples of real use cases of developing agents with respect to traditional Web 2 use cases or in Web 3 use cases, and what are the future directions or innovations in the space which you are gonna follow. So first of all, just a show of hands, how many of you will be comfortable talking about more technical aspects like frameworks like LangChain, toolings, or things like that? So just wanted to have a general understanding of the crowd so that I will try to simplify accordingly. So you might see on chat, maybe.
Yeah, we are seeing a lot of thumbs up and hands raised that they are comfortable.
Sounds good. So let's start. So yeah, the first definition, if we explain about agents, is basically agents is a type of program which tries to sense environment, which is either the runtime in as a software computer or in real time, let's say a robot, through sensors, and then try to act according to sensors to do certain changes so as to attain a certain goal which is defined. That's being very simple. It was defined by one of the well-known course books in the field of AI by Russell and Norvig. And all these aspects, how to define environment, what actions that can we do, what are the, let's say, categories of inputs that we have. All of these are define the nature of agent we want to develop. Oops, sorry, seems not. Okay, perfect. So apart from the functionality, there need, in order to create an agent, it has to have the following characteristics. Rationality, meaning that the actions should be taken in respect to a very constrained environment that was given in. So let's say, for instance, if you have created an agent which is trying to automate your tasks, it will not try to formulate a particular action sequence based upon the fact that internet might crash or certain major black swan event happens. So rationality concept means that a particular agent has to take certain constraints within environment and other policies. Autonomy means that it has to take the decisions for certain, let's say, goal or policies autonomously. It can surely have a feedback loop with humans. Then the categories of agents are of two types. One is zero-shot agent, meaning that once, let's say, user tries to interact with agents, it tries to give input as context, and it gets the result without ever checking out the history of conversations or history of all the activities that happened before in the environment. And others are the agents with memory, which try to, let's say, for instance, in a chat discussion, they try to store the context of discussion, and then the agent tries to respond to a particular action based upon the context. So if we see in this particular, let's say, model, at that time, there was no concept of using deep learning models. And this is something that was kind of constraint for these agent models to be implemented on large scale use cases. So then we come on to the current definition of agents. What are the, let's say, the evolution of the initial definition to the current context. So after, as we all know, once the transformer model came, the possibility of doing various use cases, let's say question answering or other operations, OCR, like trying to recognize image or other tasks. The powerful characteristics of transformer model made the agent use cases feasible. So agents have basically the same model is now being defined based upon major 4 use cases. One is the way you are trying to interact with the environment, trying to do self-examination by using these sensors to interact and then get feedback environment and tool. So sorry for stay. Yeah. So I'm not. So for a particular, let's say, agent, there are basically 4 components. First is how to use the sensors. Basically, sensors here are defined as tools. Tools can be various applications that we use, let's say Google search engine for accessing information, trying to get additional context apart from the information that transformer model has. Once you get the information from the environment, the second step comes as planning. Let's say if a certain prompt is being provided, how we can plan the particular, let's say, input prompt that is given, so that the agent is able to give example. And once, let's say, currently we are talking about single agent use cases, let's say chatbots or things like that. Once we want to make it much more advanced use cases, let's say trying to do a planning for a certain event or trying to create a software, as I will explain in my presentation, how we build these models. So this, let's say, Andrew Ong tried to clarify these concepts. So for a single agent, let's say, use case, there are following design patterns. One is reflection pattern, where we try to give a prompt to a particular model. This model consists of 2 agents, where one is the responder agent. It tries to take the user's input, tries to get the initial response, and then reviser will try to analyze the response from the given LLM and then try to re-execute the response. So we start with a demo. In the meanwhile, if anybody has questions, feel free to raise it. So I think Vivek has a question. What does straight shot mean? Yeah, so indeed, query, the response from the LLM, basically, once we, let's say, we send the query string to the LLM with the reference. It can be simple language and natural language text, or it can be, there is another technique called as retrieval augmented generation, which means that if you give a certain reference information and you try to include additional context from, let's say, internet, or it can be from other databases, you can include that to make a transformer model answer precisely, because transformer models have this issue of hallucination, meaning that they try to concoct the response based upon their own internal, let's say, training purposes. So yeah, I think anything, yeah, tools are essentially function calls. Thanks, Mark, for giving responses. So function calls to APIs and external knowledge sources. It can be knowledge graphs, databases, and other things like that. So let's start with here with the simple reflection kind of agent. Is here we have I think I might share also the link on the chat so that anyone else want to run their own, let's say, own query on the agent. So basically, it will have two steps. Once you try to, let's say, give as I explained, give the prompt, one agent will try to analyze the response, and then based of the criteria, whether this response has attained certain level of quality. This quality can be, let's say, a particular criteria in your function. Let's say, in our case, let's say you want to generate the best essay based upon the user's request. And you will also have to provide critique to the user. So unlike current chat applications like OpenAI, you just ask the prompt and you get the, let's say, result for any completion of responses. You don't actually get the explainability of that response, which is not, let's say, helpful. So here we, let's say, define the prompt that the criteria, the agent persona, let's say what agent should be doing. And then let's say I will go through generally from the application, but if you have certain, 1 second. Okay, sorry, I didn't execute it. So here, LangChain, how many of you know generally about what is LangChain, or should I go in greater detail? I think. So just to give a general overview, LangChain is a wrapper framework on top of major transformer models and various other modules in the space, let's say vector databases, external APIs or data sources within the internet, in order to create end-to-end production pipelines for LLM applications. So in our use case, once we want to create agent, there is we need to first define the type of prompt, basically the message that you want to transfer. So here we decide that, okay, the prompt has to be, the input message has to be of this category, that it is basically addressed to the system. So it defines the instructions of how the LLM has to respond. And then we define basically the model on which we want to run. We define the maximum length of input prompt that we can have. And then there is this way to generate the result by piping the result of prompt to the LLM input. So I think, oops, chat fireworks is not working. That's weird, because normally I have imported here the response. Okay. Named fireworks. Oops, my apologies. It's error in the runtime. Yes, I have started Mark from the start. I have installed all the relevant packages, and I have re-executed the example, but I think I might have done some error. Maybe it was due to the changes that I did. Normally, okay, let's try. Tuple of role and templates. So, okay. Apologies, that's an issue, but 1 second. Let's say I will try to check out the actual example for reflection agents. So you can follow also on this tutorial from LangGraph system. Normally it is okay. I think, okay, system needs.
Yeah, I think Mark is right. Like the Fireworks AI package is not installed. And then once you
Okay.
add the pip install and provide it an API key for Fireworks, it should work.
Okay, my release for this. So normally I will just go through generally about the steps that I've taken. So here, let's say you have first the description of the agent, then you have, let's say, generation of the response. Let's say here we define what's the requirement of the user, that you want to write an essay about certain topic that is defined, and then it gives the result. Then once the input is been prompted, then you have to it gives another agent whose characteristic is that it has to evaluate the response from the first stage of the LLM, try to generate the critique, and based upon the criteria that are defined. And then it creates a feedback loop within the LLM. Then we have, let's say, here we have to understand how these, let's say, various agents are to be integrated. For this, there is the package within LangChain called as LangGraph. Okay, so somebody shared mermaid diagram. Okay, that's good. Thanks. So yeah, thanks, Holly. Indeed, it was helpful. So let's say here we call the LLM, we send the message to the graph, and then get the, let's say, result. It's a little bit more complex, but a higher level, I think, understanding is, I think I already have mentioned in the discussion. Oops, say that's, I think where is the, so here, I think, yeah. So once the response is, let's say, generated, reviser tries to generate the feedback. And the condition here, let's say in our notebook was, I think here we have condition that it the input for creation of essay in our case example has to be generated 6 times. But let's say you can do certain changes here, saying that, okay, I want to create a condition. Let's say the response of a particular essay has to be having grade of A+. So the LLM will try to check, the reflection agent will try to prompt LLM multiple times, try to get the response in a specific format. And when the particular result comes out to be at a certain grade, it outputs the result eventually. So 1 second. Oh, wait, I have to, I think, get a file. So maybe I might have to skip, unfortunately, the notebook, but if you want to try, as discussed by Mark, you will have to add Firefly API. And normally this should be working, I think. So let's go on to the, let's say, next steps. So in the previous example that we have analyzed reflection, it's not very efficient because there is not enough reasonability about the various potential responses that came. Because even LLM doesn't have the aspect of reasonability, or there is no let's say the results can be random. So even if the criteria that we defined here was like multiple number of iterations, the final response might not give a better example. So in order to resolve this issue, we have another prompting technique called as reasoning plus acting. It has 3 different agents defined. So we have thought agent, which was similar to reflect agent. So trying to get the input prompt from the user and trying to create potential, let's say, actions. For each action that is generated, the LLM generates the result, and it gives the observation is trying to find what were the reasons for that particular output of the LLM comes out, and then user has a much clearer idea. So I think normally this notebook should be working. So let's try. In the meanwhile, any other queries? Or if you are able to understand, let me know. It's a little bit.
It's making sense. It's making sense, Dhruv. Thank you. Yeah, I'm excited. Hopefully this demo will play to the demo gods in this one.
Okay. Sorry. Yeah, it's I kind of did last minute changes. So
Yeah, in the last one, I was able to make the fireworks thing work. So if anyone wants, I'm just sharing a notebook, which,
okay.
Yeah.
Thanks a lot. Okay, so here we import dependencies as before. I do have put my open API key, but I will just deactivate later on. So if somebody has one, they can use it, but use within certain limits. But okay, so after installation, we include packages, let's say, from LangChain agents, where I will explain later on what each of these classes determine, how we can create our own agent based upon 3 categories. So LangChain OpenAI, okay. I think a little bit embarrassing, sorry. Let's see, it works. Okay, so that's good. So we import dependencies, and just for maybe people who want to understand, in the tools section, Tavily is kind of a search engine for transformer models. So it tries to search on the internet and then tries to get the response and then try to feed to the LLM in order to get short-term summaries. So it's kind of helpful to run your queries onto tools like these rather than to run directly on Google search engine or others. So we try to compile, we try to define the tools. Ability AI key. Okay. So my bad. Oh, no, we have already defined this. Okay. Normally it should be working. What else is Tavily? Okay. It's weird. Maybe I think I have to use something. Think OS.
Mark's giving a suggestion to try to delete the export.
Okay. and maybe use this, I think, get an environment variables. And this, I think, works. Normally, yes, alignment issue, indentation is done. What else? Get. Okay, I think I'm a little bit confused here. Why it's giving get out. Get env. Okay, then I think maybe I kind of missing the environment. Should be like this. No, it's college. Normally this should be okay. That's weird. And this anybody idea like I would be.
Could you link the notebook?
Sorry.
Could you just send a link to the notebook to the
Sure.
to the wall?
Sure. Sharing. Okay. Okay, onto the chat. So I'll just do a go through, but if you want to just, I think, solve this issue of getting the environment variables, we import the requirements. So first thing is we need to access the external, let's say, reference data. So for that, we use tools. So now here, in order to define the prompts, let's say we have two possibilities. One is to take the prompt standard template, which is defined by Lang Hub community template. It's also a great tool for the users who don't have defined their own template libraries to use the second references, or you can use, let's say, the same prompt template to define the agent as I've done in the reflection template. Define the LLM that you want to use, and then you use the function React agent from the LangChain in order to instantiate the agent. Then for an agent, you will have an executor class that takes input as the specific tools to access the data, the description of the agent. Then you, let's say, invoke a query with the agent. So for the agent, its persona is that it will only use the tool if needed and only give a final answer, not with other context. So once you run that, there will be, let's say, it will try to create a response, but with the reference observations that it found in the given answer. Now going back to the presentation. So in order to make it much more, let's say, applicable, this React architecture for more complex use cases, you try to use language agent tree search, which is a paper presented by, I think this year only, which tries to create tree-like instantiation of React agent. Let's say it gives a response with the observation, and then you try to probabilistically run, let's say, either of the paths. Let's say if one of the responses there, you try to reiterate similar to reflection agent to get further results. And to do this till the moment the let's say probability of getting further result comes to be negligible. So I do have a demo notebook, but I will not go too much in details to keep interest of time here. So apart from that, you the second step comes is once you try to define the nature of the agents, then next step is to understand how to plan and execute the transaction, the operations. So you can try to either define the stages. Let's say you determine what are the various tools you want to use with corresponding patterns, and what are the end, let's say, execution requirements in order to create, your specific use case, whether it's, let's say, just completion of a specific text generation task, or it is more general task. And also here we need to also define the concept of cache memory. So once you have, let's say, conversation of tasks and corresponding retrievals, you need to keep the result in this scratch pad, which is helpful, let's say, to do reanalysis and then give the result. And then tries to observe the result and gets response in the feedback loop. So for the planning and execution of the LLM agents, you have various different techniques. Let's say you try to, unlike the React agent, you try to first, let's say, sequentially define the tasks that you want to do to execute certain operation. Let's say I want to plan a ticket between destination A and destination B, given certain criteria, let's say time of destination travel, cost of living, or certain criteria like that. So typical techniques that we discussed before, let's say React plus action and reflection, will not make sense because it's going to be computationally intensive. So here we need to plan in advance. So it tries to let's say create 3 agents. Once you have a plan agent, which tries to generate specification of a particular plan, then a tasks list is executed on another agent, a single, which tries to execute each task, try to get corresponding parameters, evaluation parameters. Let's say during your proposed travel plan, you have cost as parameter, you have travel time as parameter. You try to analyze this in loop, and then you send to another agent called as replan, which tries to analyze the response from all of them. And then you give the final, let's say, tasks list, which is more suitable. And then you get the result. So, okay, so I think thanks, Sid, for working out codes. So here is plan, a simple type of plan and execute agent. If you want to try, the link is there. I think I should share the link of and the slide itself. Oops, sorry. I think I have 2 open slides just to be sure. Okay. Yeah.
And this is a naive question, Dhruv, but would you say that like the plan and is this like each one is more complex than the next? For me, React and plan and execute, I can't tell if like plan and execute is definitely more complex, or if it's like more situational when you would choose to do React versus plan and execute.
That's a good question. So yeah, it will based upon the nature of task that you want to get. For instance, in a typical, let's say, very specified use cases, let's say during discussion or where you don't have that much atomic operations, React and action will be much better use case. In some cases, you want, let's say, the output of each of your actions to be instantaneous rather than unlike in plan and execute, you will have to analyze other factors. There are more, let's say, agents or dependencies in the process. So yeah.
Yeah,
Maybe
makes sense.
That
Makes sense. Makes sense. Yeah, it does. It does. Thank you. Thank you.
Yeah. So so sequential plan and execute was a simple version, but let's say in more complex use cases, you will have to have, let's say, in certain operations, the tasks can be executed parallelly. Let's say, for instance, you need to schedule certain, assignments on different subjects, for instance, like to get answers to different facts which are given as prompt. So for that, you have another second kind of technique called as LLM compiler, which is also named as streaming compiler. There, what you do is, unlike typical, let's say, planner agent, single task agent, and replanner agent, planner agent tries to create tasks in parallel, and then you try to create a graph of dependencies of each of these plans, let's say with unique aim and unique destination. That graph, once you define this whole graph in the storage, the replanner just will have to iterate over this particular tasks steps. After execution, once it is able to, let's say, get the best path throughout this graph, it will be able to generate the result and respond back to the user. Maybe people might not be able to understand how there are, let's say, various algorithms which allow the agents to analyze which is the, let's say, most optimum path in the various tasks. Let's say Dijkstra or traveling salesman problem, or things like that. But basically the essence is like that. Here is this example notebook which is available. If people want to use, there is to try to copy this notebook and implement on their side, there is this technique to GitHub to Colab, which is able to connect directly a Python notebook to Colab notebook, and people can, let's say, fork, and you can try to execute from your side with custom prompt inputs and your own parameters. So going ahead, yeah, so LLM compiler is, like, say, parallel and reasoning with operations observations is similar to that of once we have React agent is trying to, as Vivek said, like how we can, let's say, is it possible that for a particular use case, React is better, and particular use case, I think plan and execute is better. So we try to merge the both the fields both ways, let's say, agent architectures to create best of two. So here we try to create, let's say, a planner agent which tries to create a task list, and there is a worker agent which tries to run this particular description tasks by sequentially chaining the, let's say, the results that got from previous, let's say, plan, and then trying to send it to another one. So it's kind of recursion execution of the plans and the corresponding results. And then solver tries to update the final, let's say, plan, and then responds to the user. Till now, any questions? Or I think I'm not able to get the message chat, chat. So one second.
And no questions. Yeah.
Yeah,
Go ahead. Go ahead.
No, yeah, we can help you with the chat, Dhruv. I don't see any either. No.
Perfect. So, I mean, plan and execute agent technique of creation for the agent use case, it's great, but there are improvements that are needed. It's all the, let's say, the results that are coming. There is no way of, let's say, there is not way of analyzing the nature of response that is given. Although it is able to give the observation, additional context, but let's say for use cases, dynamic use cases, let's say the sorting algorithms in a supply chain or any, let's say, robotic use cases. So you don't know for a particular task that is given, let's say putting a particular object to another, let's say B, A direction to B, you don't, let's say, able to get reasons from any of the agent techniques that are defined before. So these plan and execute agent use cases are not applicable there. So we need to, let's say, integrate another layer of algorithms, let's say deep learning, reinforcement learning algorithms, where the policy to plan and take the better operation is defined by mathematical algorithms. So I will not go into depth in this detail, but if you want to have a reference, there is a paper from DeepMind regarding some of these algorithms like Q star. Hugging Face has a course on this topic, so feel free to check it out. So yeah, after explaining all the different agent techniques, I just want to summarize the way how we want to write agents is basically you have to define the 3 steps. One is what are the potential actions that agent can do. In our case, it's just, let's say, the generation of text, but you can also program it to do multimodal actions. You can also do, let's say, apart from calling, you can also have a lazy execution saying that, okay, the agent will only respond after a specific criteria of result it gets from the LLM model. You have intermediate steps. Let's say in the example that we have explained before, there were 2 or 3 agents that were communicating regarding the nature of responses that is got sequentially, but you can have more dynamic interactions also, or message passing between agents to make each others aware about the current state of response, and based upon the nature of technique that we are using, generate final result to the user. And then finally, what is the final state of the result that agent has to respond to the user. It can be specifically defined in case traditional use cases, or it can be infinite in case of, let's say, distributed agent execution that I will explain later on. And second thing is, till now I haven't explained how the concept of memory works here. We consider, let's say, memory is just a temporary storage of intermediate information, or the reference information that a tool tries to fetch from external sources. But how this, let's say, memory is managed in order to get more relevant, up-to-date information. It's also a major thing that we have to consider while writing agents. So for memory, there can be of two types. During our, let's say, execution of various agent architectures, we mostly used cache memory. It can, let's say, store sequential discussions of chat. It can be also token buffer memory, meaning that unlike the chat discussions of the user and the timestamp information, you can have, let's say, a buffer information with a limited context window, saying that, okay, the agent has a certain constraint, and it has to, you have to develop algorithms to ensure that this constraint memory should be only storing the information which is relevant. Let's say it can, let's say you can use certain algorithms saying after certain previous date, you can erase that specific memory and replace it with certain other information. Apart from certain, let's say, storing directly text, you can store specific information like context memory. I think there is this very nice article by Comet ML, which is another ML ops framework, which explains this in detail. Might not go much in description, but feel free to look it out, and it has an example notebook for that. So cache memory, apart from cache memory, we should also have long-term memory. As we all know, the other, let's say, relevant information, let's say data stored in SQL databases, which are private. You also have certain, let's say, frameworks which allow you to query across this data and then store it as a context for agent to ask relevant, precise queries with the transform model. You have various ways to access it, either with NoSQL databases. It's PG vector framework, which is very popular. For vector DBs, you already have relevant Python SDKs for Pinecone, Marco, and others. And third thing, in this long-term memory, the most important aspect we have to understand is each access to this database is much more costly. It takes enormous, let's say, more time to access with respect to cache memory, which is under milliseconds. So we need to understand, like we need to implement various algorithms. So just like before I explained for token buffer memory, we need to, these algorithms will help us to get in a much more, let's say, less complexity, the possibility to get precise information. And some of these algorithm is Bloom filters. If any one of you know, like it's already implemented in Ethereum and other blockchains. So it basically tries to give, let's say, a reference flag that in a particular block, whether a certain transaction hash is included or not. Or like you have, let's say, intermediate cache, which tries to store the relevant information, and whether if in case an agent tries to access this memory and it doesn't get the relevant information, it means it has to be fetched from long-term memory, and then only we will access the long-term memory. Okay, so now we were talking only about, let's say, a particular, let's say, use cases where you have a particular user and a series of agents trying to work on a specific task. But we can consider more complex use cases where you need to have multiple agents working on various aspects of a particular query parallelly or sequentially. So for these multi-agent workflows, you have each agent having a particular custom prompt, specific tools that it wants to use, and how to collaborate in order to create consensus. So it can be done by various ways, trying to do message passing, or trying to use various tools which are based upon, let's say, the intermediate planning or whatever category of algorithms that agent used to analyze the better prompt and getting the result. So there can be approaches are either to develop domain-specific agents, trying to fine-tune agents to access specific model, or trying to optimize the tool, the use of architecture. So hierarchical agents is the type of agents where you have you have different categories of let's say differences between the nature of agents, how they can communicate with LLM, what are the specific tasks that they are required to do. Let's say if we have a complex query that I need to aggregate the data source and create a matplotlib. In this use case, I think this demo should be working because I tried to execute already. Here I essentially run a query to generate matplotlib, let's say the graphs for a query regarding what is the current nature of investment in the Web3 space. So let's say I will not go much more in detail, but the workflow is pretty much simple. You determine the worker node, which is gonna do actual hard work of, let's say, using tools to fetch the relevant information. You will have router agent, which tries to basically pick specific worker node that has to execute at a particular time, get its response, and then try to, once each worker nodes does their very precise task that is defined in the function definition. So here, as I think Mark has discussed before, the function calling method. So function calling is basically you define the specific type of function with the parameters that you want to call without actually defining the working code. And then you have the final, let's say, the router agent, which defines, okay, given the conversation by the user, I need to delegate to which node, and once I get all the result, I will just give back the output. So once all those agents is defined, just like previous nodes, agent architectures that we have developed, we try to create the dependency graph between them. And then here comes the user query. And let's say here are the specific executions from the, let's say, main router graph and the individual worker graph in the middle. So, and here is the result.
Dhruv, I'll just pause here to say that we are on top of the hour. So if anyone has to go, yeah, in the interest of time, please feel free to leave. Like some of us can continue, whoever is free to continue for the next minutes.
I really appreciate those who want to go. No worries, and apologies in case I was had hiccups in the first few slides.
It's a part of the learning process. Yeah, thank you everybody for whoever has to go. We understand. Dhruv, thank you, and please feel free to keep going for whoever can stay. And
sure.
Thank you for everyone.
Yeah, I will not go much more in detail. I mean, pretty much the demonstration part is done. Further, it's just theoretical and questions. So let's say after explaining the multi-agent workflow use case, I mean, I will just want to give supplementary information that there is another LangChain blog that I referenced here, which gives a very good example about, about the various categories of additional, let's say, workflows that you can create. I will share in the chat also, and I have added in the references. Unfortunately, I'm not able to access the chat. My bad. Yeah, okay, good. So it's really, let's say, one of the most important blogs on understanding why the more complex, let's say, use cases, let's say, search engines can be implemented by this architecture. So going ahead, one of the use cases that I really was impressed by initially, I mean, it was trendy, was trying to create complete, let's say, a SaaS development company by defining custom agents representing various departments, from UI design, from coding the specifications, from testing those program packages or specification, and then doing the documentation. This project was ChatDev, which was referenced by Andrew Ong in its article. It basically uses like a collection of all the various techniques that I've defined before, but with more, let's say, advanced techniques of how to memorize the descriptions, let's say, from either team to other, trying to also do, let's say, reasoning on the particular tasks, and then trying to take, let's say, the best response of either of two, because there are lots of, let's say, unknown ways there can be collaboration based upon the category of, let's say, type of methodology, software development methodology use. Here, it was using just waterfall, but you have agile, scrum, others. And this was some of the challenges that I noticed. It doesn't follow the some of the basic, let's say, concept of writing clean code, building architecture that is resilient in the code. There should not be breaking changes in the API, how to define the data model in the application, or things like that. And yeah, so this is something that I think needs to be improved in the while building these use cases. It can be an ideal demonstration, but we need to realize there will be always room of improvement. Some of the important ecosystem references that I referenced, and I will also give like people who are really interested in understanding the various productionized agents in the space, is E2B, which is a cloud sandbox provider, which where you can run all of these agents. Let's say some of them are runtime agents, which you need to have a secure environment. They provide this by creating a sandbox for each of these agents so that you don't execute harmful code. And it's a very, let's say, neat description of various agents in various domains. So yeah, it's my like the best recommendation. And the various frameworks, right now I only used LangChain because of modularity, the granularity, sorry, of various, let's say, APIs that it provides. It has much more robust documentation, but you have, let's say, others also, let's say, sorry, it was Llama Index. Here I did a mistake, but it's not LLM. 1 second. I think, yes. So,
yeah, Dhruv, there's 2 comments. Like David suggested that are there AI agents which transact on chain already on behalf of their owners? Like the example he has given is a weather station agent which buys weather data from independent sensors and transacts. Do you have an example within crypto where we can use this?
Well, there have been, let's say, use cases more specific to executing intents. I think there were, I wanted to create a specific slide for Web3 specific agent orchestrations. but I was not able to find, let's say, very convincing description of how they define the actual technicalities, like, because on executing on chain, like it's not a major issue. It will be let's say off chain compute execution by, let's say, services like functionless, serverless applications. There were various, let's say, other challenges that I found, like how to have a consistent data. Also, the challenges of not being front run, to have consensus. So maybe just to answer specific question, I think I haven't seen the like consistent use case for, let's say, real world data to be executed on agents. But there's project like OLAS. It has created its own registries of various agents that run on intents. Maybe you can check it out, Mattis. But I will be happy to, let's say, exchange afterwards on Slack, once if I'm able to come across one of the use case. What specific?
Holly has an interesting comment.
I think symbolic kernel indeed is a good framework, or alternative of LangChain. I had to do a course on deep learning AI. It tries to define a specific, let's say, description, or like, how to say. I mean, it's a good course where it explains the semantic kernel tries to formalize, tries to create recipes or specific ways of executing agents without being, let's say, for specific domain use cases to make it more reliant. Indeed, I would also recommend people to follow the course on deep learning AI to how to use semantic kernel. Yeah, and any specific other questions?
Yeah, not a question, but Holly has a comment which says AI agents make up 50% of the safe transactions on Gnosis chain through AutoNodes.
Okay, that's interesting insight. Although I use safe core AA wallet, but I didn't have idea. But thanks for this insight. I'm gonna check it. Indeed, and maybe eventually. So,
and some participants were asking about the links to the slide. If you have it.
And then another question, Mark, please go ahead.
Hey, thanks, Vivek. Thanks, Dhruv, for this very insightful like overview of agents. You know, I played around with both LangChain and semantic kernel in the past, and see how helpful it is in terms of like prototyping LLM applications. But you know, and maybe this is an observation, and I would love to hear you or everyone's take on this, is that as models become much more optimized, you know, I believe that at some point we may not need frameworks like LangChain or semantic kernel, because the models become much more robust. It could be as simple as saying, hey, here's what I need to do, and the model actually does it, you know. And so I'm wondering, like, is it still maybe helpful or useful to learn these frameworks? I think from a software dev perspective, I think it's very much like a great onboarding tool to sort of like learn about these things, because, you know, it pretty much just speaks their language, right? But at some point, I think the models are just becoming so good that we may not need this anymore. I wonder what your thoughts are, Dhruv.
Indeed, that's a very good argument, and I will surely address this in just maybe the next, let's say, 2 slides. I wanted to introduce the 2 of the most, let's say, current cutting edge, model development approaches. Let's say how we can make any multi-layer perceptron model. It can be, let's say, transformer model currently case, or eventually there are other alternatives coming, let's say state space model, CANs, and others to be much more optimized. But at the same time, I think they will still have certain, let's say, constraints on the level of complex, let's say, information that they can use. I mean, right now, the use cases are very much restricted to getting, let's say, text feed, let's say, information on certain, let's say, operations or like doing knowledge insight queries, which is done by either a specific person or for an organization. But if you want to implement very, let's say, complex use cases, let's say deploying ERPs, let's say SAP, for doing complex financial transaction information operation, and for instance, in DevOps, you want to orchestrate, let's say, infrastructure for a big, let's say, company. So you want to, in all these various use cases, the amount of information it's going to come, it's going to be very complex. Even if you have a one model, it has robust, let's say, memory, let's say, understanding of memory, good understanding of specific domain. It is fine-tuned, it is optimized, whatever optimizations you can do. There will be always this, how to say, a weak link is like scalability, in my understanding. There will be kind of this trilemma will come in AI operations. So in my understanding, in, let's say, current future or 1 to 2 years, my understanding is the current, let's say, various frameworks that are created, these frameworks will have to be made more reliable, and these will stay. These will be complementing the performance of transformer or whatever models that are going to come. So yeah, that's yeah, maybe that answers query. Or hello, Mark.
Yeah, Mark.
Oh yes,
typed out
yes,
in the, yeah, go
it
ahead,
did.
Mark.
Yeah, thank you, Dhruv. Yeah, yeah. I think you make a good point there. At least from what I understand, is what you're saying is that this framework is still useful because it's sort of maybe, at least in my head, constrains it to a certain maybe like task. Instead, because models can like generalize so well, and it just has information on everywhere. If you are, say, a company or an enterprise with a specific use case, with specific domain knowledge, it's useful to use frameworks like this. And it's always going to be improving across time too. So yes.
Yeah, thanks. I think others have queried. Giza indeed is a good project on Stack where I had chance to trying to do, let's say, verification of model, putting proofs on chain using their Orion library. So indeed, they are. It's a good project, but I think for specific, let's say, the use case that I've used is trying to put the performance parameters on chain to proving the verifiability of a certain computer execution. But I haven't, let's say, seen maybe using Giza tech as similar as using transformer library of Hugging Face to execute the model also on chain. So that I haven't seen, but if maybe Yuan, you have idea, feel free. I'm able to check. I haven't seen what like say improvements are there in Giza for a long time. So I think I was just gonna wrap it up quickly. So I think I was, yeah. So some of the Web3, let's say, agents that I think are gonna be very important in the upcoming use cases. In DeFi, for instance, trying to create specific domain, let's say, agents try to analyze intents given by user, and then accordingly trying to instantiate, let's say, transactions using account abstraction to execute certain operations, or investments, liquidity, provision, or whatever, based upon portfolio risk potential. governance also, I think there is immense opportunity how to analyze the proposal and trying to fund it retroactively based upon the nature of progress, which is verifiable. And I think another most important, let's say, use case that we should be, let's say, there was a lot of concerns raised was how restaking should be done for Ethereum in a way which keeps better balance between the potential reusability of node architecture, but at the same time keeping consensus security also. And so future research domains that I already discussed with Mark is some of the, let's say, how we can see evolvement of these agent architectures in various simulation environments. So let's say AI Town, which is a good open source project, kind of mixture of playground of a typical, let's say, 90s game with agents which have specific initial seed prompt. You can say the character persona, and they try to interact with each other. They use memory to have discussions, things like that. Or it can be for physical use cases, like trying to create agents which simulate bodies in, let's say, Unity game engine or Mijoko open source engine, which was used by OpenAI Gym. There were, I will just give a general brief view. Badger is one of the architectures that was proposed by this company called Good AI. And the idea was trying to create long time learning distributed agents, which tries to, let's say, interact with each other, interact with the environment. Each of these agents have different, let's say, specific memory and specific requirements. They try to interact for whatever operation from real-time use cases, try to get parameters for their let's say, model, like observation, what were the potential rewards. So these all parameters are to be fit into reinforcement model. And then they try to improve their performance within with each of their memory for the next step. And then there is another loop of this algorithm that tries to improve the, let's say, let's say, the response of overall architecture. So it was a, let's say, project where that was deemed to create agents to be much more realistic in a game setting environment. I mean, they did example in 2020, but if you want to check it out, how things are progressed, I will suggest you to go into their website and check the Badger architecture. It's good. And another vision that Jan LeCun also given to how to create agents with models with much more realistic responses, much more, let's say, doing by self-supervision, is this model where you have, let's say, 8 different components. So you have a perception, like this model, it's kind of a let's say, within the foundational model, you try to create all those various components to interact with the environment, get feedback, then try to also take into consideration the constraints in the actual environment. Let's say you don't take into account there are limited resources, any other aspect that we humans, the intelligence that we have gained throughout our evolution. So the let's say, vision of Jan LeCun is trying to create the same, let's say, mimicking the same concepts that we have in our traditional, let's say, neurological intelligence in the actual, let's say, creating models with trying to create embeddings in those models with various different concepts. So that's pretty much it. Conclusion I would like to give is, so agents have, let's say, 3 major, let's say, patterns in order to develop architecture based upon the prompt techniques: reflection, react, Another is memory references based upon constrained memory, unlimited memory, chat memory, or information they store. And then based upon the communication, if it's just a, let's say, single hierarchy agents or multiple hierarchy agents that I've explained before. LangChain, for me, it was a preferential, let's say, framework that I used. And then various real-time use cases, both in Web 2 and Web 3 space, require much more evolved evolution in the various agent development frameworks in order to make it much more reliable. And yeah, that's pretty much it from my side. Thanks a lot. And really, it has been 90 minutes presentation. Hope all the other people, I mean, half of the people were there. So I really appreciate you guys to be there. And yeah, thanks.
Thank you, Dhruv. Appreciate it.
Thank
Good
you,
to see
thank
everyone.
you, thank you, everyone. And thank you, Dhruv. This was like one of our first AI keynote talks almost. And like it just sparked many more conversations. Like Mark is interested in hosting another session on audio related language models. So we look forward to like a much broader AI series overall through these sessions. And because today's session was focused so much on like interactive agents, like the session on Tuesday where Andy will discuss playing with AO, that will give us more insights into how interactive agents could be possible using technologies like AO. So if anyone is interested in RWeave or AO or just listening to Andy, like most of us are, please feel free to join this session. I'll drop a link to the conversation here. And some of you are already like RSVP'd to this conversation. And yeah, David, there's many links in the chat, which will, in the convo, which will help you understand what AO is. So yeah, we look forward to seeing some of you there. And thank you for coming to today's session. Thank you.
Thanks.
I'll stop the recording now.
And thank you, Sid.
Thank you.